So now we are going to consider multiple linear regression analysis after we have completed simple linear regression analysis. If you can remember, simple linear regression analysis, we had to consider one independent variable as an effect to the dependent variable. However, multiple linear regression analysis, we are going to consider more than one independent variables and see their effects on the salary. So we can focus on all these variables as salary, which is y, as a function of x1, which is years of previous experience, x2, which is years employed, x3, which can be years of education, x4, which is gender, and x5, that is department, and finally x6, which is number supervised. But still we have to consider etc, meaning that there are some other variables which may affect salary, but they are not mentioned. And so after creating this, then we need to come up with a hypothesis to explain this assumption, where we have the null hypothesis and alternative hypothesis. And in this case, we're going to look at the slopes of all these variables to see which slope is equal to 0 or significantly greater than 0. So the null hypothesis will be that the slope is more or less the same as 0, and therefore we'll consider the p or the probability, which is 95% confidence level. And alternative hypothesis will be that b, or the slope of any of this, will not be equal to 0, will be significantly different from 0, and that can be proven by the p-value, which is greater or equal to 5%, and this is the significance level. So that's the probability, the hypothesis which we will need to prove. Let me highlight the hypothesis. And now we can write regression model as y, which is observed y, equals to y-intercept, which is, we write the coefficient, which is a, plus, now we're going to consider slopes, or the slope of each variable. So we will consider the slope of the first variable, which is x1, and that is the years of previous experience. And we will add, in fact, we will add assuming that salary and years of previous experience have positive relationship. However, if we know that the relationship is negative, then we will actually put negative here. So now again, we're going to add years employed, meaning that the more years you are employed in the company, the more your salary will be. So we're going to plus the slope of that second variable, which is years employed. Years of education, we will put the plus sign, meaning that the more years of education you have, the more salary you may have. So in this case, we're going to see the slope of that effect, which will be d3x3. Let's see gender. So we're considering for gender, we have 0 for female and 1 for male. And so our interest is all about male. And all we are trying to do here is to see if is the gender the source of your income, meaning that does your salary depend on your gender. So for now we can add, and so we have B4 X4. Department, it all depends on the department that you're working at. So we can as well add that for now. So let's go B5X5, and finally we are looking at the number supervised, meaning that your salary will depend on the number supervised. The more people you're supervising, the more your salary could be. That's an assumption. And so in this case, we're going to have B6X6. Still, we will need to include the error term. So we're going to add the error term. So that's the observed salary, and all this is estimated salary, and E is the residual. So we can actually write Y estimated, which will be A plus B1 X1 plus B2 X2 plus B3 X3 plus B4 X4 plus B5 X5. So that's the estimated salary. And in this case, we're going to do this estimation. And we'll test the slope, these slopes, to see which one is significant and which one is not. So we can run regression, and remember, we can go just to the data and see if you have data analysis, and I will select the regression. And then all we're going to do is to determine the Y range. Remember, Y range is the dependent variable, and that is salary. So I'm going to select values for salary, and I have included the label, which is salary, and therefore in this case I will select the labels. Now let me define X range. So now we are going to consider more than one variable. So we could take 2, 3, or even all of them. So let's consider all of them together. So these are the multiple independent variables. We'll check the labels, and constant is 0. Confidence level is the same. But the only thing I'm going to do here is, now I'm going to select output in the same area. However, let me see where my output should be. That's perfect. Or let me select output to be here, the output range. I'm not going to post residuals or even to plot the lines, but I'm going to keep the residuals. So I can click OK. And you can see we have the summary output here. And so let's look at regression statistics. In this case, you can see that we have multiple R, which is 0.91, and that shows that there is a positive correlation between estimated Y and Y observed. So in this case, we are looking for the correlation between the y observed and also and y estimated. So to see if there is any correlation. You can see the correlation here is 0.91. That means there is significant correlation. Actually, it's approaching 1. So it is really good correlation. And we are looking at the R squared. We can see that about 82% of Y observed is explained by the Y estimated. So in that case, it means that all independent variables together can explain about 82% of the salary, which is good. Now, adjusted R squared also, it's it's almost the same. It is 79% of Y observed is explained by the Y estimated, and the remaining is not explained, but which is not as big as the portion that is explained by our variables. The remaining percent is actually the error term. And so in this case, since everything is okay, that the multiple R is significant, and also the adjusted R squared or the R squared is okay. So we can go to the outcomes to validate the slope of each particular variable. So here you can see that we have coefficients, and we have the coefficients for y-intercept, and also we have coefficients or the value or the slopes for years of previous experience, years employed, up to the number supervised. In fact, we can rewrite our estimated model as y estimated equals to the y-intercept, which is this value here, which is 19589.5, and that will be plus this particular value. And let me copy this, and I'll paste it here just as let me see if I can paste there. Oh, so that value is there, x1. Hold on there. So let me rewrite this. So we have y estimate is this particular value, and instead of plus, you can see that we have minus, and that's the output. So we're going to rewrite the minus, and that's for x1, and then we're going to add years employed coefficient, which is, let me copy this, and I'm going to add here. And so I will add, because years employed is we can add, and so I'll add this value for years employed, and we can add all of them up to the end. You can see gender is minus, and so we're going to minus this. So I'm going to stop the video and copy all these values together, and if you can also, you can do the same. So let me stop here. So I have copied all the values in the model, and you can see we have y-intercept, which is this value, and here we have minus, and that's for years of previous experience. It gives us minus, although we cannot have minus relationship between salary and years of previous experience. But now we're going to see why this is negative. But anyways, we are going to put minus here depending on the outcome. And so we have minus of this value x1, which is years of previous experience. We have 6 to 1.06, which is this one here, and that is the slope for x2, and x2 is years employed. We have also this one for x3, which is years of education. Now, gender gave us minus this value. So instead of plus, we are going to put minus this value, which is the slope of x4. But this is positive, the department and number supervised. And so we're going to add all these values for x5 and x6. We are not considering residual because all we have is the salary estimated, or the estimates of the salary. So now, given all these values or the coefficients, we are going to find which coefficient is significant or not based on the hypothesis which we have created here. Now, remember, the slope should be different from 0 and significantly if the probability value is less or equal to 5% significance level. And so if you come down here, we don't have to consider the p-value for the y-intercept, but we'll start with this slope of years of previous experience to see if it's significant. And so we're going to see this p-value here, which is 0.62. So this probability value is greater than the significance level, which is 0.05, and therefore this value is not true. It's almost 0, so it is not significant. This probability value shows that years of previous experience is still not significant. And we will look at the years employed. You can see that this probability value is actually significant because it's less than 0.05, because we have this exponential here that says that we have 0.50146. So the p-value here is almost 0. Here as well, we have 6.101 E-05, meaning that we're going to have, meaning that it is 0.50601. So this also is almost, the p-value is as well 0, which is good because it's less than 5%. So years employed and years of education are significant. Now let's look at the gender. We have minus, but you can see we have the probability value, which is 0.29, which is greater than 0.05 significance level, and therefore gender is not significant in our estimation. Now let's see department. Department, we have 0.001, and this is less than 0.05 or 5% significance level, and therefore department is significant. Number supervised is not significant because the probability value is greater than the significance level. So in this equation, we will just consider factors that can affect salary. And in that case, gender, let's highlight gender, which is not. Number supervised is not. And now years of previous experience is not. When we consider multiple regression. So in this case, all we can do is to remove number supervised, gender, and years of previous experience, and keep years employed, years of education, and department. Those are the factors which, when we consider multiple regression, in this case, are significant. So you can see, for instance, years employed that has 621.06. This value, or the slope, is significant because of the probability value. Years of education on itself, you can see it is 1631.831, and this value is significant based on the probability. Now here we have minus 1654.07. This is not significant, and it is not because of the probability. And here we have 2134.29. This value by itself is significant only because of this probability value here. Now, this amount for number supervised is not significant, not because of the figure that we have, but it's because of the probability value that is here. So in this case, number supervised, gender, and years of previous experience can be eliminated, can be removed from our equation. So I'll remove them. That one is gone. Now the minus 0 on this one. And the number supervised. So we could actually leave variables that are significant. We have 3 of them. So we have years employed, years of education, and department. So we can use this to explain salary. Now we can explain or estimation of our salary on each factor by itself, and we keep other factors constant. For instance, in this case, we can say that salary can increase by this amount, which is the slope. Sorry. So salary can increase by this slope when x2 changes per unit, holding other factors constant. And this is the years employed. So a year of employed in this company will increase this amount to your salary, holding other factors constant. And also we can explain this one, which is the years of education. And we can say that a year of education will add this amount, holding other factors constant. And finally, we have our department. So it all depends on which department you're working at, moving from one department to another. So that's one move, will add this amount to your salary when you hold other factors constant. So that's how we can explain the outcome of our multiple regression analysis. So you can try by yourself to consider 2 or 3 factors. You can take salary as a function of years of previous experience and years employed, or you can take years employed and years of education, or years employed in gender, years employed in department, or years employed in number supervised. So you can mix them up, or you can look at few of this or even all of them and see what kind of results that you're going to get. Thank you.